Hey, welcome. Today we're going to be showing the beginnings of working with nodes in Blender by creating a single node that allows us to generate 4 different shapes, control the size, and control the fall off of these shapes. Okay, let's get stuck in. I'm going to be working in Blender 2.82. If you're working on a previous version, I recommend you come up to this one, which is currently the stable release. I'm going to be working in this view space today. Yours may look different. So I've got my node space, which is big because we're doing nodes, and I've got a small 3D viewport in here. The work that we're going to be doing is entirely with nodes, so it's important that you've got the Node Wrangler add-on enabled. If you've watched any other videos, I'm sure you will have heard this 100 times. Node Wrangler in your add-ons in Blender preferences, just make sure this box is ticked and it will add a lot of additional functionality that's going to help you streamline the process. A little bit of node etiquette. When you have the Node Wrangler add-on installed, if you Control Shift and click on a node, it will give you a preview of the socket. If you keep clicking, it will click through the different sockets and you will see what each of them displays. The next thing we're going to be using quite a lot is I do Shift right click, and this will add reroute nodes. Just keeps things a little bit cleaner. The other one that I'm going to be doing quite a lot is the scalpel, which is Control right click, and that lets you sever nodes. Very useful. We're going to be making 4 shapes, right? Circles, squares, triangles, and hearts. And I feel like these will give you a good understanding of what we're doing with nodes, because it's not just about putting a shape on a crosshair. We're not just saying draw a circle here or draw a square here. What we're saying is these gradients describe values, right, from 0 in the middle to, in this case, 1 and -1, although this is actually an infinite gradient, right? So it's just that the amount of it that is currently on our object is 1 to -1. Hopefully this will make more sense as we work through. What we're going to be doing procedurally is we're going to be generating shapes from these values. So we're not saying put a shape on top of this using the location. We are taking the X values from 0 up and actually below as well, and the same for Y. So for all of these, we're going to be using object coordinates. Something I like to do is I like to press Shift Tab, or you can also go up here and tick the magnet. This will just snap your nodes to the grid, keeps them neat. And then also I like to hide unused sockets, which you can see is Control H. So there we go, Control H. First one we're going to be doing is the circle, and what we want to draw a circle is we need a radius, and we want this radius to be the same all the way around. So basically we want to be able to define a length. Now Blender has a node that does this very easily, so Shift A, Converter, Vector Math, add this on top. You can just drop this on top of a node to release it from the node there without breaking the noodle. I just held Alt to pull it off, and you can just drag it back onto the noodle and it'll splice in. So we can change this from add to length, and you can see that this has given us a gradient out from 0, 0. Now how this is calculated is it's using Pythagorean theory, a squared plus b squared equals c squared for a triangle with a right angle like that. So we want to know what this point is here. We want to know what that is, and we have the x and the y coordinate, and we want this to equal this distance here. The value of this point is equal to the distance. We can say that to get c, right, this side, we can get rid of that by square rooting everything. So just to display that, we are going to use a converter, separate x, y, z. You don't have to do this, but I feel like understanding exactly how everything works will add to your ability to manipulate what you're doing later. So please bear with me. So we're taking our x, as you can see here, and we are squaring it. We are taking our y, and we're doing the same. We are then adding these together to give us that, and then we are going square root. So you can see that this and this, the output is identical, and that is how the length node calculates that value from the vector input. It was important to recognize that this is not just dropping a radial gradient on that point 0, 0 is calculating each value of each point on the surface based on its UV coordinates, based on that formula that we just did. So what if we want to get rid of some of the edge and change the size of it? Well, everybody has different ways to do this. My way is to use a mix RGB node. Just going to drop on here. First thing we're going to do is we're going to set this to color burn. And we're going to set the value to black on 2. Now you can see that as we increase and decrease the factor, this changes the size of our gradient. Now if you clamp a node, it basically means that it is limiting the output to be between 0 and 1. Color burn and color dodge will always clamp the output. So this is only 0, it's not less than 0. If that makes sense. Now to decrease the fall off, I'm going to be using a color dodge node, and I'm going to set the value of this one to be white. And now you can see that this is bringing the whites in, and this is allowing us to change the scale. You could alternately use a convert math node and set this to greater than, and this will give you control over the size of it. Basically say, is this greater than 0.35? Yes, no. That's how that works. It's just a binary output. Issue is that you get very hard edges, whereas this allows you to control the edge. Lets you have it completely hard as well, but lets you have a bit of softness if you so wish. Another way that people do this is with the color ramp. Color ramp is one that is again super useful. It lets you bring up the black and it lets you bring in the white. This is nice, but it requires you to move these flags, which you'll see later when we put all of this into a group node. That's not very useful to us. You want to put this in a frame, Control J with the node selected, N to bring up your information panel and change the label to circle. The next one we're going to be doing is squares. So how are we going to get squares? Well, we're going to be doing a little bit of separating and then joining back together. So separate x, y, z. So this is going to give us a readout for our x and our y. What we want to do is we want to have this mirrored on both sides because we want our square to be dead center. To do this, we're going to use something called absolute. The notation for absolute is 2 vertical lines. So what we have here outputting is x, but it's absolute x. We're using the vector absolute. There is also an absolute on the normal math node. This one will take a single stream of information, that's what the grey means. This one will take a triple of information, that's what the purple or yellow mean, is they will take 3 streams. Very useful because we now have absolute x and absolute y. Absolute basically makes all values positive. So -1 becomes 1, -3 becomes 3, but also the positive ones remain positive. What we can do with this is we can add our color dodge and color burn, mix RGB, color burn, have our X go into here, set this to black, color dodge and color 1, set this to white. So now what we have on our X is we have the size and we have the fall off. Going to do the same for Y. What I did right there actually is probably worth noting. If you want to duplicate a node that has its inputs, then rather than doing Shift D and reconnecting it, you can do Control Shift D and it will keep the noodle that goes into it. Very useful. So now what we've got our X and we've got our Y, and we're going to be using a function called smooth maximum. There are 2 ways that you could have done this. You could either go add and then you can clamp the output. This will give us this at the corners. What I'm actually going to be doing here, rather than using add, we're going to be using another function on here, which is going to be called smooth maximum. And that is going to basically take the maximum value at each point. Just think it has a nicer fall off on the corners. This is now our square. So now that we've done our squares, we're going to select all of this, Control J to put it all into a box, and we're going to call this one squares. Next one we're going to do is triangles. Now how do we get an equilateral triangle when we've only got horizontal and a vertical gradient, bearing in mind that we want the center of the triangle to be at 0, 0? Well, it's actually not as hard as you might think. If we have an axis and we want to draw a triangle like this, well, because we want the center of it to be at 0, we also know that when the size is 0, this gradient is actually going to be here. What we know is that this triangle has a value of 60 degrees here, and this is a right angle, and that it passes through 0, 0. So we know that y equals some, this is a negative gradient, some negative constant of x, and it goes through 0, so plus 0, which we can get rid of. We can therefore say, because we want to know, for doing our nodes, we want to know when this equals 0. So what we can do is we can say y plus kx equals 0. And then from that, all we need to do is create this formula with nodes. So what I'm going to do is I'm going to add a converter, separate x, y, z. Now we want the absolute of x, but only x. So this is mirrored, but the bottom line just wants to be the bottom line. What we're going to do is we're going to add a math node, add x, set this to absolute. So now what we've got here is our mirrored x values here. So we've got absolute x times some constant that we don't know what this is, and then we're going to add y. We're just going to take this y value. So as you can see, we've immediately got a value here, and if we change what this is multiplied by, then you can see that that is rotating these two sides. Now if I mute, press M, then you can see that this gradient, it continues on into the x region, but with absolute, it's only considering positive integers, so we get this mirrored appearance. We also want to do something with the horizontal axis, right? So we want this to be white below and we want it to be black above. What we need to do, this is our y-axis, we need to invert it. So I'm going to go multiply by -1, take y into this, and there we go. So now we have our upside down. Just like we did with the squares, we're going to be using smooth maximum. Drop that in there. So you can see already that we've got something that resembles, well, certainly 3 points. What I'm going to do just before we work out what the constant is, I'm going to add the dodge and burn just like how we did before. So burn first, and I'm going to add the dodge afterwards. Now, how do we work out what this k is? Well, k is the gradient. We know that we have a triangle, and we know that triangle is right angled, and we know that this value here is 60 degrees. So what we can actually do is we can say we have opposite and we've got adjacent, so it's going to be tan that we want. We're going to be using trigonometry, and this constant here, the constant for the gradient, is equal to, we can say tan, we need to be working in radians, so 360 degrees, a full circle, is 2 pi, so 60 degrees is 1/3 of 1/2 of a circle, so 1/3 of pi. We can just type in here pi divided by 3, and that will give us our 60 degrees. If you don't want to have to do that maths, you do not have to. You can say this is going to be 60, output is 2 radians, and that's 1.047. Pi by 3 is our angle, and that is our constant. So now if we look at our triangle, you can see that it is a perfect equilateral triangle. Hey, okay, just pausing there, this is future me. So I just realised while editing this that I haven't actually explained properly why it is that we're using tan here, tangent. The idea is that we need the constant that describes this gradient, right? So if we have our graph and we have a line coming down it, then this line has an expression, right? So it's y equals, let's say, totally arbitrarily, that this has a negative gradient of 2, so we can say minus 2x, and let's say it passes through here at 3. So this is how we normally describe a line. Now we want to know what this gradient is, but all we have is this angle. For our triangle, for our equilateral triangle, this is going to be 60, because equilateral triangles are 60 degrees interior angles on each corner. And the reason that we use tan is because the gradient is the rise divided by the tread. And with trigonometry, we know that we have a right angle triangle, we've got the angle, and we have the opposite side, and we have the adjacent side. In this case, we do not have the hypotenuse. Because we're using just opposite and adjacent, that is why we use tan. So this is theta. Tan theta equals opposite, which in this case is y, over adjacent, which is x. So y over x is rise over tread. So that is our gradient. If we can find out what this is, then we have our constant, and we know that tan of theta equals this. So that is why we are using tan of theta, which is our angle, which is 60 degrees, but in radians. And 60 degrees is the same as pi divided by 3. So that is the reasoning of how we got to using tan here. I hadn't explained that at all, so I just wanted to come back and say that real quick. Okay, back to the other one. So I'm going to put this into a group, and I'm going to call this one, and to bring up the panel, triangles. So we've got one more to do, and that is hearts. So hearts, obviously a little bit more challenging again. For us to be able to draw a heart shape on our axis. Fortunately, we are working with a symmetrical shape once again, so we only need to consider half of it. The first thing that we can think of is that it's like a circle that has been smushed upwards on the outside. We know how to make a circle, and that's going to be our first port of call. I am going to take the object coordinates, going to take a vector math node. I'm going to plug it in here with the length. This is going to give us this, and just so that we can get a clear view of what we're doing, I'm going to start off by adding in our mix burn and our mix dodge. We need to do something in here that makes the circle get distorted. So the first thing I'm going to do is I'm going to separate XYZ, and then I'm also going to combine XYZ, and I'm going to select both these. I'm not worrying about the Z, so I'm just going to do Control H to hide it. What we can try and do is say, as X increases, we need to subtract Y from it. So first of all, let's just add a math node in here. Let's set that to subtract. Now you can see that we've got this shape here, definitely distorted, but what's happening? Well, we only want to be considering positive X values and not negative X values. So to do that, we're going to add an absolute node into our X string. There we go. Okay, so we're well on the way already. Now, I think if we add constant in here, then we get a little bit of play in our lateral scale. So that's nice. We've got a little bit of control here. There is an actual mathematical formula for doing a heart. X squared plus y squared minus 1 all cubed, subtract x squared y cubed. You can just have a look at what that one looks like. So this is what this heart looks like. I think it's probably the most common heart shape that people use, but it doesn't go down to the 0 scale, which is what we want for our node, because we want all of our shapes to come out at the same size. I'm going to group all of these things together. I'm going to call this one hearts. Now, we want to make a group node, a single node that will allow us to output 4 different shapes and control the size and control the fall off. So to do this, we're going to select all of the nodes that we're going to put inside. We're going to do Control G. Control G is going to allow us to make a group node. You can see everything's going to go green here. If I tab, then I will tab in and out of this node. So at the moment you can see that it's called node group. I'm going to rename this one shapes. So if we go into it with tab, you can see that it's now gone green. We have a group input node and we have a group output node. Output is called color. We are going to want to have our 4 outputs as circle, square, triangle and hearts. Because we are only outputting black and white information from each of these, I'm going to set these to single streams of information. I'm going to add 4 outputs and I'm going to delete the color one that was automatically generated. When you generate a node group, if you have noodles that are coming into it and off of it, then the group will automatically generate sockets for each of those noodles, and it's going to also automatically name them and create automatic default values, max min information. So with these 4 outputs, I've just clicked add. This will add a single stream value like a grey socket. I'm just going to rename these ones to circles, squares, triangles and hearts, and then I'm just going to plug these in. I have texture coordinates on the inside, but we want to have our vectors coming in from the outside to make us able to use these shapes in future projects. Because at the moment we have 4 streams rather than plugging in independently from the group input. I'm going to do shift, right click and drag over the noodles, and this has created 1 reroute per initial one, right? So it's clumped them. Now these 2 are actually together, so I'm going to do that like that. So we now have all 4 coming out of this one. If you want to get rid of this, you can't just press X because that will delete the noodle as well. To dissolve it, you can do Control X, which will dissolve vertex like it would do in 3D modeling, or you can do Alt drag to get rid and then delete it once it's disconnected. So I'm going to plug from my group input. You can see that we've got this grayed out socket here, transparent socket. If I was just to add an input, then we would have a single line of information. If you plug vectors through a grey socket, they're going to get compressed into a single line of information. So we can't do that. What we need is we need a blue one. However, when you plug this transparent one into any socket, it will take on the attributes of that socket. So in this case, purple. This one, we can just change the name of that to vector. So this is going to be our vector input. Next, what we want to do is we want to have a slide factor for our scale and our fall off. Because we want that slide, I'm going to plug that right on in to the factor there. And then I'm also going to take another one and I'm going to plug that one into the factor of the color dodge. So the first one we're going to call size, and the second one we're going to call fall off. And then I'm going to plug these in, size into the burn, fall off into the dodge. There we go. And now on the outside, we have shapes. You can see that we've got a vector input into which I'm going to plug in our object coordinates. Now you can see that we've got our circles, our squares, our triangles, and our hearts. And on all of these, we can change the size and we can change the fall off. So now we have a very simple group. If you want to add this to other materials, it will be on your Shift A group. Anything in your file which is a group will get added to this list. So now you can see that we are adding groups in here. Now this default value thing is a bit odd, 0.75. Let's say that you wanted that to be different. It's in here. You can select the socket for the interface on your node settings. Select the default value. I'm going to change mine to 2.5 just for both of those. And then I'm going to just make sure that has happened. And now when I add them, we have this here. If you've been following along, you will have this group node with 4 different shapes and a size and fall off control. There are many more shapes that you can describe mathematically using this process, but hopefully this video has just given you an introduction and an overview of how we can use UVs to generate textures. You can get really deep into this, and we're going to be using this node group in the next lesson, where we talk more about generating vectors in order to transform and manipulate our UV coordinates. So hopefully this video has been useful. Thanks for tuning in, and I'll see you in the next one.